Okay, so now that we have a firm sense of limits, in this video, we're really going to get started in one of the fundamental branches of calculus. Okay, so we're going to do a little thought experiment. So we're going to have a graph of a function. So this is a graph of a function. So this is our function f of x. So there's our function f. Now what we want to do is find, let's call this point, this will be x, and this will be delta x. Sorry, not delta x, this will be f of x. Y-coordinate will be f of x. Now, we want to find the line tangent to the graph. Okay? We want to find the line tangent to the graph, the slope of the curve at that point. Okay? So you might know what a slope of the line is, hopefully. You know how to find the slope of a line. But the slope of a curve is constantly changing. Here, in this region, the slope is negative. The slope is less than 0. In this region, the slope is greater than 0. So it is constantly changing. Even here, the slope is 0. The slope is 0. So you have the slope constantly changing. However, we're going to use a little thought experiment to help find, or at least conceptualize, how to find the slope of a curve at one point. So let's have another point over here. Okay, and this point is delta x units away. So this will be x plus delta x, and the y-coordinate will be f of x plus delta x. Okay, since we have a function f. How would you find the slope of the purple line? How would you find the slope of this purple line? Okay, so you would find it using the slope formula. M equals y2 minus y1 over x2 minus x1. Okay, hopefully you know that formula. So we're going to apply it to the purple line over here. F of x plus delta x, that's our y2, minus f of x. So let's just write it a bit better. So f of x plus delta x minus f of x over x plus delta x minus x. So the change in y over the change in x. So the x's just cancel, and we get the slope equal to f of x plus delta x minus f of x over delta x. Now let's move the red point. We're going to move that a bit closer to the blue point, x. So let's put it over here. So this will be our new x plus delta x. Okay, This will be our new x plus delta x. And this will be our new delta x. So let's draw our purple line. So the purple line is basically our approximation line. It's known as a secant line because it's sort of like the secant of a circle. Hits the curve at 2 points. Okay, so you can see it's a bit better in approximating the slope of the tangent line. Here, for this one, it was not even close. Not even close. This one has a flatter slope compared to the slope at the blue point. This one is a bit steeper. So you can see that this approximation is sort of working. Okay, let's move the red point even closer. So now it's over here. So now this, just erase that. This is x plus delta x. And I won't even write delta x, but this green arrow is now the new delta x. So I'm going to draw the purple line now. And you can see that's almost identical to the tangent line. It almost hits the graph at 1 point. If you were to draw the exact graph, it would be very, very close to the graph of the tangent line at the blue point. Okay? So the tangent line is the line which intersects the graph at only 1 point. This still intersects at 2, but it's closer to the actual slope of the curve. The slope of the purple line is closer to the slope of the curve. However, what are we doing to delta x? We had delta x to a reasonable amount here. However, we're starting to get closer and closer to 0. So why don't we take the limit as delta x approaches 0? So as the red point gets infinitely close to the blue point, what will the slope value eventually turn out to be? So as limit as delta x approaches 0, what will the slope? We already found out our slope expression up above. What will our slope value turn out to be? Well, you will, since as the red point gets infinitely close, it eventually starts to get so close it almost overlaps. So as it approaches 0, slowly yet surely, it will approach the actual slope of the tangent line at that point. The actual slope of the curve at the blue point, which we kept fixed this entire time. Okay? So the limit as delta x approaches 0 over delta x will be the slope of f of x at the blue point at x. Okay, and this is a key tenet of calculus and is known as the derivative of x. The derivative of f of x at x, which you can write as f prime of x. F prime of x is basically this, evaluated at x. Okay? And we're going to actually get to see what evaluating a derivative for a function, how you actually do it in the next video.